Question 7 says the concrete sections of a certain superhighway are designed to have a length of 23 meters. The sections are poured and cured at 10 degrees Celsius. What minimum spacing should the engineer leave between the sections to eliminate buckling if the concrete is to reach a temperature of 41 degrees Celsius? And you can see table 1 for the coefficient of linear expansion for concrete. So here again we're going to use the equation for linear expansion, and what it is the change of length is equal to the coefficient of expansion, and that's times the initial length times the change of temperature. My pen quit working. Times the change of temperature. And so it's asking us to find how much spacing should be left in between the concrete. And so imagine that this is our roadway, and we're putting extra wide gaps in there just for effect, but there's going to be several of these, and so this thing, when it expands, let's change the color here. Let's say that when this piece right here expands, it's going to expand a little bit that way and a little bit that way. And then this one, when it expands, it'll do the same thing, a little bit that way and a little bit that way. And so what I'm trying to show is that this one gets half of this space and it gets half of this space. And so in essence, the total expansion is going to equal one of these, since half of one space plus half of one space equals one whole space. Each concrete slab gets one whole space, and so this amount of space that it gets to that you would want to put in between each one is equal to the entire change that one concrete block will make, so the entire change of L. So we don't need to find the L initial, we don't need to find the L final, we just need to find the total change. So we don't need to expand anything, we just need to plug in our numbers, except for change of T, you could plug in T final minus T initial. The final temperature 41 degrees Celsius, the initial temperature 10, so to me it's just as easy to say the change of T is 31 degrees. And so from table 1 that you can link to, the coefficient of linear expansion, alpha, is equal to 12 times 10 to the negative 6th, or you could put 0.000012. And so you multiply that by the 22 meters, and you multiply that by the 31 degree change, and the answer you'll get is going to be in meters. So 0.008556 meters. The answer it asks for in centimeters, so you just multiply this by 100, you move the decimal over 2 places, and you get 0.0855. I don't know why I put another 0 there, so 0.8556 centimeters. So erase that 0.